Sensitive data detection used to have a map. In a database, you could look at tables, columns, field names, and sample rows. The structure told you where to start. One column contained social security numbers. Another contained email addresses. Another contained credit card numbers. Even when a company did not know exactly which columns were sensitive, the discovery process had structure. You could sample rows, infer the data type, classify the column, then apply masking. The hard part was not always easy, but at least the data lived in predictable places. That changed when sensitive data moved into documents. Open a 100-page PDF, and the map is gone. There are no columns, no field names, no clean labels. Names appear inside paragraphs. Addresses are mixed into descriptions. Phone numbers show up inside emails. Credit card numbers may be buried inside invoices. Now the system has to read the text and decide what is sensitive. That is why named entity recognition, or NER, became useful. That helped with document protection. Instead of inspecting columns, NER models read natural language and identify entities like people, organizations, and locations. It also identifies phone numbers, addresses, and account-like patterns. That helped with document protection. But documents were still bounded. You were usually scanning a file, or an email, or a known body of text. AI workflows changed the input surface again. How sensitive data can show up inside a prompt, a pasted email, or an uploaded PDF. It can also appear in a retrieved RAG chunk, a tool response, or agent memory. It may even show up in an MCP call, or the model's final answer. And all of it can be part of one interaction. That turns sensitive data detection into a runtime problem. You are no longer scanning a stable database column. You are inspecting data while it moves through the prompt layer, retrieval layer, tool layer, memory layer, and response layer. The first failure mode is noise. Humans do not write clean inputs. They misspell names. They paste half an email. They write incomplete sentences. They mix shorthand with formal business language. They upload one document and ask a question about another. A detector built for clean patterns starts to struggle because the signal is messy. The second failure mode is partial context. A user may not enter a full account number. They may enter only the last 4 digits. That fragment may not look sensitive by itself, but combine it with the previous message, a retrieved customer record, or the user's identity, and it can become sensitive. That is where simple pattern matching starts to fail. The system has to understand context across the interaction, not just match one string in one input. The third failure mode is language. An employee might upload an English document and ask a question in Arabic. A support team might paste a Spanish customer message and ask for an English summary. A user might mix 2 languages inside the same prompt. Sensitive data detection now has to work across multilingual and mixed language inputs without blocking everything useful. The fourth failure mode is business-sensitive context. Enterprises do not only care about PII, they care about discount terms, pricing strategy, contract negotiation details, legal reasoning, internal financial commentary, customer-specific risk analysis, future product plans. These do not always have fixed patterns. You cannot mask every percentage. You cannot remove every number. You cannot block every paragraph that mentions a customer. A 20% discount may be public in one context and confidential in another. The sensitivity depends on who is asking, what task they are performing, where the data came from, and what policy applies. That is the real difference between traditional data masking and AI data protection. In databases, sensitivity was often tied to structure. In documents, sensitivity was often tied to entities inside text. In AI workflows, sensitivity can come from entity, context, user intent, retrieved data, tool output, memory, MCP calls, and runtime policy. If detection is too loose, sensitive data leaks. If detection is too aggressive, the AI loses the context it needs to give a useful answer. If detection is too aggressive, the AI loses the context it needs to give a useful answer. That is why finding sensitive data is much harder in the age of AI. The hard part is not only masking the data. That must happen without breaking the quality of the response. In the next video, we will look at the second half of the problem. Once you find sensitive data, how do you protect it without confusing the model or making the answer useless?